Okay, so this is being recorded and will be posted online. Hi, welcome to the Web Performance Working Group. Today we have a special guest. Jonathan Mayer is here to talk about an HR time issue he opened regarding the monotonic clock while sleeping. But before we dive into that, just on the administrative front, the next call is scheduled for May 27th, the same usual time, so on Thursday, 10 a.m. PST. If anyone has issues with that, let me or Nick know, and we'll see what we can do about that. Otherwise, I thought of starting with a small issue related to performance timeline. Nicholas, do you want to discuss that?
Sure. So I was looking into implementing dropped entries count. As a recap, it's basically trying to surface when there were dropped entries from performance observer callback. And given that it's a number instead of a Boolean, it surfaces how many. So the question that you have posed during the implementation phase was, is it confusing that the count increases on each callback, in the sense that once the buffer becomes full, every new entry will add to the count, and it doesn't matter if the observer was already there. So in order to accurately measure how many dropped entries you had, you would need to use the number from the first observer callback. And maybe that's confusing. So one potential solution is to basically freeze the number once it becomes non-zero, right? So the first time there were any dropped entries. And that way you would kind of, if it's non-zero in the first callback, then you know how many dropped entries there were from the start. If it becomes non-zero after, then it doesn't really, like, you didn't drop any entries, but it still tells you when the buffer became full, basically, which is kind of another use case to know, like, does this buffer actually become full at some point during the page load? So I was wondering if people had thoughts about which one is less confusing, or if there's a better idea.
So Nicholas, my understanding is that part of the problem with anything to do with like drop buffers or clearing buffers, with what we've tried to do in the past with resource timing, I think, was there could be different consumers of this API that could register observers at any time, and they might read a different number. And so if you froze it, it would be based on the first reader that registered as an observer.
Oh, right. I should clarify that it would be frozen for each observer. So each observer would have to keep track of their own numbers.
Got it.
So yeah, it's just more memory, but maybe less confusing.
Yeah. So that seems fine. That seems consistent. I'd need to think through it more for like more concrete feedback. But one idea that came to mind as you were describing this problem was, for event counts, we already have like a total event count for things that are under threshold for the, like, you just have a total number of events, even if you don't get the full details. I wonder if it's possible, rather than saying, here's the number of dropped entries, if we could just have a total count, and then you could keep track yourself of how many you've read and compare it to the total, and then you can infer if there were any dropped. Like, I wonder if it wouldn't be both consistent and potentially more useful for other purposes. And then you don't have to deal with this growing number, you know, that you should expect this number to be updated over time. Just throwing that out there.
So what concerned me about like the current API shape where the number keeps growing over time is that people will be confused and think that despite the fact that they registered an observer early on, they still have entries that are being dropped despite the fact that they're actually observing them and registering them and reporting them. So I'm wondering if, Nick, you're kind of like Nick and Andrew, maybe on the consumer side, of the API. Do you think that this is potentially an issue, or would you which variant would you prefer? One where the number keeps growing, or one where it's frozen per observer?
I think I agree with you that if the number would keep growing, it could lead to other developers potentially being confused about it. I think, like those in the know, or those that have read the spec very closely, or those that would fully understand the issue could easily get it. But like it's like a very minute implementation detail that they would have to be aware about, or we'd have to have like a big explanation block in the spec to make sure that people fully grok it. So yeah, I kind of like the idea of it being frozen per observer. I guess I haven't fully thought through what that would mean, but I think like in our case, we would probably only be reading it at the beginning anyway, just to get a general sense of what we missed. I wouldn't imagine that we'd be rereading it. But I could see somebody in like developer tools, looking at their observer callbacks and just happening to notice that it's increasing every time or something, and that being confusing. So that's why I think that having it a little more frozen or consistent might be nice. I don't know. I guess I haven't thought through it fully yet, though.
Yeah, I think I agree in essence, but I'd need to think it through myself as well to make sure there wasn't any reason I'd wanted to keep growing and get that value.
So, yeah, go ahead.
Michael, was your thought for like the total count or whatever that would be just a global thing available, or would it be on the observer, or?
I was thinking it would be exposed the same way. We could describe thing, but the problem fundamentally is like semantically calling it num dropped. It's surprising if that keeps growing. You're like, oh, more dropped. Like, am I just not noticing? And so I see where the confusion would come from, but just renaming it to total entries or total count or whatever, which we already do elsewhere, that is less unexpected now if that number keeps growing. And the two numbers are equivalent because you have a fixed buffer size, which you could read, and the buffered amount plus the num dropped equals the total, and that number does grow. I think could be a case being made that fixing the number of dropped at the time of registering the observer could also be potentially surprising in other cases. I don't know. I haven't, you could just rename that to like num dropped at the time that you registered the observer or something like, which is the use case here.
Yeah.
I think the advantage of having it dropped and not total is that if that is non-zero, you immediately know that the observer is incomplete. Whereas if you have a total number, then now all of a sudden you have to choose to track that and compare it to the amount that you read. So it's less obvious.
Yeah, I agree with that fully.
So I guess for the specific use case, the most valuable sounds like fixing it to the numbers that were dropped at the moment of registration. Then you immediately know something happened without the risk of confusion.
Right. But then would we freeze it at 0 if the observer was just registered fast enough? Or would it be useful to have basically a rough estimate of when the buffer becomes full by the number becoming non-zero? That one, yeah, I'm not sure if it's potentially confusing that it just suddenly becomes non-zero and then freezes.
I see. So you're saying for the case where like the observer is registered at the beginning of the document, the buffer is not yet full, it later becomes full.
Right.
Okay.
Because I remember, did you have another proposal that wouldn't solve that case? Because if we're not planning to solve that use case, and we can do the just like a polling method in performance, right? Like what?
Yeah, theoretically, we could also add a method on the performance object, saying like get number of dropped entries per like for each type, and decouple that entirely from performance observer. But that would mean that we don't get the signal of when the buffer becomes full. I don't know if that signal is important.
Yeah, my main worry is that it becomes really hard to know exactly when you have to query the numbers to ensure that you're not missing the buffered entries. So that's why it's nice to have it coupled in the observer, where it's the browser's responsibility to make sure that the number is correctly computed, so that if you drop entries, the number reflects that, right? Whereas the polling method, it's a little, well, it depends how you do it, but yeah, it's a little trickier.
So, sorry if we jump, but if we're going to freeze the number, is it useful to still have a number, or does it effectively become a Boolean at that point of, what was this PO?
It's useful for, like, for example, for Run. Like, let's say it was resource timing. It would allow us to know how full the buffer should have been by the time we got there, which could give guidance to the page to increase the buffer or something like that. Or, even for things like resource timing, if you missed 1,000 entries, that may convince the person including the analytics to include it earlier in the page, the script earlier in the page, or to register the observers earlier, rather than miss that whole wide swath of entries. So I do find value in knowing the quantity.
Yeah, so what I'm hearing is that there's general support for freezing the value more than leaving it as is. But would it, I mean, the hurdle here is that we like in terms of shipping, this is more or less ready to ship in Chromium, but it would be a shame to ship something and then realize that we shipped the wrong thing. So I'm curious as to what we could like do on that front to have more confidence. Maybe Nick and Andrew, could you you both said you're supportive but need to think about it a bit more. Would you be able to do that kind of thinking and comment on the issue in the next few days, saying yay or nay?
Yeah,
absolutely. And I guess the thing, like overall, like the value that this brings is immediate. With the knowing the number of dropped entries is great, and the just the ergonomics around whether you might be confused about it increasing or not, like I think are smaller than the value that it brings just knowing that data. But yeah, definitely think through, see if there's anything else I can think of why we wouldn't want to do it. But yeah.
Cool. Okay. So next up, should we? I don't know if we should maybe. Nicholas, for the event timing one, I just don't want to keep Jonathan as he's.
Yeah, sure. He can go first.
Yeah.
It's fine. Yeah.
Okay. So we are talking about HR time 115. Maybe I can present. So, Jonathan, do you want to talk through the issue?
Sure, thanks. Thanks, Yoav, for the invitation to join today's call, and thanks, Nicholas, for the initial look at the issue on GitHub. So, as context for the issue, my research group at Princeton is using the HR time API for a project that involves monotonic timing across web pages. This quickly became a very deep rabbit hole involving the history of the spec and browser implementations of the spec, browser clock implementations, OS clock APIs, and eventually hardware clocks on x86 and ARM. I'm happy to talk about any of that as helpful, but I'll try to sort of stay at a high level of the stack. So there are 4 suggestions I made for possible revisions to the HR time spec. All of the suggestions are, I think, or at least I hope, are very consistent with the intent of the spec. The first is to clarify what behavior should be during system sleep. There was prior discussion of that. It seemed like there was consensus on that. And so that would just be a clarification in the current text of what that behavior should be. The second suggestion I had was taking what is currently an informative note, albeit an informative note with a should in it, as Nicholas noted, and turning that into normative language. And the reason to turn the sleeping or suspending behavior into a normative note is that's needed to implement the goal of the spec that you can compare monotonic timestamps across globals. Right? If you have the clock sleeping or suspended on some globals, at times it's not on others, those clocks are going to go out of sync, and so you can't compare the clocks. So that's the second suggestion. The third suggestion I'm actually going to flip to deal with last, because I think it's the most complicated. So let me do what is in the issue, the fourth suggestion, and then I'll do the third suggestion. The fourth suggestion is just a terminology suggestion, that the way the term clock skew is used in the spec currently is kind of different from how that term is usually used in computer science or electrical engineering. And so I thought just for clarity, it might be useful to use a different term. So the last suggestion I had, which is the third in the spec, is clarifying the semantics of what you get when you add performance.timeOrigin with performance.now. Obviously, there's zero guarantees about how that's going to compare to the system clock, because the system clock can change at any time for any reason. Right? The user can just go and change it. But there are some useful properties that could be defined into the semantics of adding those two values. And in fact, if I understand correctly, browsers actually already have implemented that or are close to it with the changes that I suggested elsewhere. And so it would really be reflecting semantics that browsers already provide rather than change in the semantics of the addition of those two values. Anyway, I'll stop there. I'm happy, again, answer questions about any of this. And of course, you guys are the experts, so I defer to your judgment about how to address these things.
So first of all, I wanted to say thank you so much for the issue, and it's it is a great issue, well thought out and well articulated. So thank you for that. Also, thank you for the last bit that you added about various OSs and their different clock behaviors, which I think would be useful for implementers that will tackle this. I think that the suggestions for clarifying what we do when like in sleep mode, moving that current note and make it be a normative should, like both of those make sense. And yeah, and changing the terminology for clock skew, similarly, I think we can align on whatever the rest of the industry uses, and I'd be happy to like take suggestions on that front on what term we should be using instead. And then on the semantics front, I'm generally supportive, but I wonder if this is like, I wonder if this is testable in some way. Like similarly, also for sleep, I don't think that we can't have web platform tests for what happens when the user goes to sleep halfway through. And for the semantics, we could have various comparisons for those timestamps compared to day.now, but we cannot enforce like users changing their clocks or things along those lines. So I'm wondering, what do folks think about that? Like, first of all, are there any objections to those clarifications and changes? And what do folks think about testing?
I guess the only problem I see is that most clocks seem to be not behaving properly during sleep, according to the table. So the concern is that if we change we can try to change the clocks, but that's probably a massive effort if the clocks being used also report internal metrics. At least that's the case for Chrome. So that's potentially could risk some breakage, especially since it requires just altogether changing the clock, if I understand correctly, right? Because the same clock's not going to just suddenly start behaving properly. So
do you expect that internal metrics are somehow like relying on the fact that the freezing behavior is the way that it is right now, or I
wouldn't expect them to rely on it, since it seems on Windows they don't rely on it. I might just anticipate some metrics to shift in unexpected ways, in particular for high percentiles, because suddenly sleeps count as long portions of time instead of no portion of time, which is the contrary to what most metrics would want.
So a thought on how this might be made easier for implementers that occurred to me and previously occurred to someone working on Chrome was rather than changing the current underlying browser clock implementations, adding another clock that just has well-defined behavior. And the idea being for legacy users of the current clock stays in place, document what it does on different platforms. And then for users of the browser clock that want a guaranteed behavior during sleep or not during sleep, they could use one of the clocks that has those better defined behaviors. There's actually a whole proposal that someone on the Chrome team put together to do that very thing, in part to address this issue. And Firefox actually already has a version of that in place. So there may be a less painful transition available if switching the underlying clock were painful.
Yeah, that would have a smoother migration process. I'm not sure that lowers complexity, but in terms of having to maintain two clocks and the confusion that would arise from that. But yeah, it could be a path forward. You mentioned that like Benjamin, Sean, do you know what the situation is for Mozilla? Like with Firefox, you already, like, how bad of a problem is it for Firefox to align with that proposal?
I mean, I think this is doable. Is that your question? Are you talking about like adding, instead of performance now, like monotonic clock now? Is that what you're talking about?
No, so there is no, this proposal doesn't suggest an API change. It just suggests to clarify that the semantics of performance.now will guarantee, or should is not a guarantee, but still it would say that it should, for example, not freeze when the tab is throttled or frozen or the system is asleep. So the clock keeps ticking when any of those things happen. And
as opposed to sleeping, as opposed to not doing that, which is the current behavior.
Yeah.
As opposed to not doing that, which is the current behavior apparently in Firefox on Linux and Android, but you all are doing a better job on Windows and Mac compared to Chromium, which is only doing that on Windows, and Safari, who's not doing that anywhere.
Yeah, and to be clear, this is already in the spec, so it's just basically we're all bad browsers that don't comply with the note that we agreed on a long time ago. So it's thanks, Jonathan, for reminding us.
You know, it's part of academia to be a gadfly.
So Jonathan, you mentioned that the alternative was to support two clocks, which might make it easier, and that Firefox already does this. There's some differences across platforms, but are you saying that already today there are two in place on a single platform?
Yeah, so let me maybe spell this out a little more in terms of how OSs tend to deal with it, and then how Chrome and Firefox currently deal with it. So OSs tend to provide multiple clock APIs that vary along at least two axes. Monotonic clock APIs, I should say. One is, does the clock tick during system sleep or not? And the second is the clock subject to monotonic adjustments? So for example, your NTP client might figure out that like the physical oscillator in the clock is off a little bit. Are you allowed to incorporate that into your clock logic or not? right? That's the kind of logic we can turn on or off in some of these APIs. So that's what OSs offer. With respect to what browsers support, in Chrome, there's currently one monotonic clock implementation that has this inconsistency across platforms. Firefox actually has, depending on how you count, 2 to 3 implementations that are used in different places. The main implementation is much like the Chrome one, and similarly has some varying behavior across platforms. But there are other implementations actually already in place in Firefox, at least one of which specifically gives you the option of calling the API with or without sleep included. So the notion of having multiple clock implementations in the browser already exists in Firefox, and in Chrome was a proposal by someone on the Chrome team, but does not exist in Chrome yet.
Jonathan, so you're saying, I guess for me, I would rather see this fully specified with both options, where you can call monotonic that sleeps and monotonic that doesn't sleep, and or with adjustments. I guess I'd rather see this fully specified than us to kind of randomly pick defaults or not. I don't know. Thoughts?
So you're saying you want to change the performance.now API to allow users to pick those options?
The thought wasn't to change the API, but to have actual clocks that are named doing what we say they do, or have a way for that to be determined. Like, we're just setting underlying defaults here.
Yeah, so a web developer calls performance.now, and then what clock is being used, or can they add an options object that picks which clock they want? Like, is that what you're suggesting?
Yeah, because like, how does a web developer now know what clock they're getting, how it's been adjusted or not adjusted, or if it sleeps or doesn't sleep? Is that just like something we're going to define in the spec concretely right now?
I suspect that this is not something that I wouldn't expect most web developers to care deeply about that, to be honest. Other than using it to detect sleep, which yeah.
Well, no, that issue's come up already in event timing, right? For long-running tasks, we've already had that issue.
I'm not sure what issue you're referring to.
Hang on, let me find the issue number.
So I guess if I recall correctly, we decided that sleep needs to tick because like, what was the reason that we decided like we needed to tick during sleep? I remember we did discuss this, but I'm a little confused right now what the rationale for it is.
It can create a drift compared to date.now, which is potentially confusing. And especially if we have multiple tabs that some of them are frozen and some are not, and you compare timestamps between them, that can create all
right. But are these clocks not using a shared infrastructure, like only the system slip would, like they would basically all be frozen or all not be frozen? Is that not how it works? Maybe Jonathan knows, since clearly he's the one that knows most about the clock slip. I don't know. Like, obviously, if it's possible for like the clocks to be frozen for one frame versus another frame, then that would be pretty bad, right? Because like you mentioned, that would cause it to be impossible to compare the timestamps across the different pages or frames, basically. But if it's not the case, then it's also, like, it's harder for me to see the main.
I think that the initial discussion where I think no, maybe like, yeah, okay. I think that issue number 65 was mostly focused around frozen background tabs and clock skew in those cases, and wasn't what didn't really discuss the entire system is at sleep mode case. From the fact that this was brought up as part of the background tab freezing implementation, I suspect that this was a real implementation concern.
So to answer Nicholas's question about could you do this across web pages running on different threads and processes and so on, yes. So the way the spec is currently drafted, the issue of frozen tabs is combined with the issue of sleep. You could have a spec that says you can't stop this from ticking when a tab is frozen, but you can stop it from ticking when the system is asleep, and you could use the operating system clock API for a monotonic clock that doesn't tick during sleep to implement that. I think it might be kind of counterintuitive that you have one guarantee around frozen tabs, but a different guarantee around system sleep. I think there's probably a reason you guys considered those issues together last time around. And I think there probably is some issue of implementer expectation, right? So folks are really familiar with date.now. That obviously ticks during sleep. If performance.now had the opposite behavior, that might be pretty counterintuitive for some implementers.
I think, Jonathan, you pointed out, though, that date.now can teleport if a user changes their system clock, which maybe is not that common, but this could theoretically already happen. Like, is somebody expecting them to be in sync?
So I think at least one group of people who thought they would be pretty close to in sync was my research group. We were kind of surprised by this behavior, which is what led us down the rabbit hole. I think at least for us, there was an expectation when we started using the API that performance.timeOrigin plus performance.now would, barring a clock change, the user goes in and changes the clock, be pretty much the same as date.now. Not necessarily identical for reasons I touch on in the issue, but pretty close. That clearly isn't the case. And I think there are good use cases for that, right? You might want a timer that is both monotonic and roughly approximates real-world time if you assume on browser startup real-world time is about right. Those are the semantics we were relying on, we found useful for our use case. And I think for any sort of precise timestamping of events across web pages use case, that could be quite useful.
Yeah, I think it makes sense for them to, like, I think it makes sense for us to be able to account for periods of time where the tab was frozen or the system was asleep, and not pretend like they just didn't happen. And events of user changing their clock are things that, that would cause a drift between date.now and performance.now, but it would be good if, barring that, they would be more or less aligned in terms of the underlying, like the underlying time would be the same time in a way. I don't know if there's going back to Benjamin's point. In my view, there's no, like, I don't see a strong use case to exposing like the ability to pick the clock to web developers so that they can, choose to ignore timestamps. And if we were to do that, it would have to be something that is not on performance.now, but because performance.now is being used in all the different metrics that we measure, it would be something that would impact all the timestamps. So it would be like some sort of like document policy that dictates a different clock. And I just don't see why people would do that.
Just to add a layer of complexity here, if you wanted to implement that, which in a spec, which you could, right? You could write a spec that gave options like that in the same way operating system clock APIs already give options like that. In addition to changing performance.now and every place that's used, you would also potentially have to look at time origin, timestamps on events, etc. Because you have two separate monotonic clocks, so you'd have to track all that activity across both of the monotonic clocks, which seems like a lot to deal with.
Indeed. Yeah.
Hey, I was just gonna double back. It's performance timeline 105. I was wondering if that applies here, or this could help solve that.
105. That is already
Performance timeline, not HR time.
Oh, right. Sorry. It's still already fixed, and I should close this issue. But that seems orthogonal. Like, this is about providing like some signal of the backgrounded status and potentially like when tabs were backgrounded or not. And we had a whole discussion around the visibility observers. But still, if we it's true that if the clock stops when the tab is invisible, that would skew a lot of those, like, I think it would have an impact on the discussion around visibility observers, which is, like, I don't know, Nicholas, this is currently on hold, right? Or
right. So there was the visibility observer discussion, but we haven't gotten on the same page about that yet, I guess. Because there's the question about pre-rendering and how it fits into that. But so yeah. I guess this made me think that the one potential reason you would want a clock that's frozen sleep is that you're just measuring a time delta between two events, and the work just freezes when the system goes to sleep. Then it just creates the potential for that duration to be super long for no good reason, unless you explicitly are looking out for, the tab froze, which is not really something people generally do, I think. Unless they actually do use the hidden state. Actually, I don't know if hidden works all the time when you freeze, when you go to sleep. Like
Yeah.
if you're visible and you go to sleep, I think it doesn't trigger hidden state, so it's even worse. So yeah, that would be a problem.
Yeah, there are also no guarantees that visibility and like, you know, a tab can be frozen after a certain timeout based on the implementation or other heuristics. And yeah, there's a bunch of like, there are no strong guarantees on that front. Okay, so if that's the concern, I can.
It's not really concerned. I just felt like if there's a way to get these clarifications into HR time and fix some of these other issues, which may or may not be related, about like how do we count time on frozen things, then we should take this opportunity to try and make sure it fits for both. That's my plea.
Yeah.
Because now it seems like often some of our time stuff is very inconsistent about accounting for sleep or idle or whatever, frozen time.
Yeah, but right now we can't, like the current situation is that we can't really rely on it because it's different on different platforms and different browsers. But what I would expect as a solution to this problem is to make sure that we report timestamps for the time spent in sleep, and at the same time have some sort of this tab was frozen observer, or some indication after the fact. So when the tab goes back from being asleep, we have some entry or some indication that this happened, and that would enable people to account for that lost time. So they will know that time has elapsed, and
we're getting somewhere. So you're saying like add a frozen time to performance entries, maybe?
Yeah.
Or whatever, TBD,
yeah,
but like
that.
mark that gap somewhere in the entry timeline. I would be up for that. I think that sounds like a good approach.
Yeah, and it sounds to me that the way there would be to start from aligning all the clocks, but yeah, it would require some basically, yeah, we have made that agreement in the past. We just need to do the legwork to implement that. And yeah, the appetite for that, I think, depends on the technical complexity which at least on the underlying tone from Nicholas is that it could get very complex. So it will require some more research, I'm guessing. Nicholas, is that a fair statement?
Sure. Yeah, I mean, there's the doc written by someone. I don't know if they ever followed up, so we could talk to them, right? Because it's pretty related. So, but I think it's good to try to align at least, because right now we all have different behaviors, just depending on what's the convenient thing to do in each OS, I guess. And that's kind of not ideal.
Yeah.
While on the subject of differing behaviors, I appreciate you all have already been very generous with your time. I just wanted to briefly mention that there was another deviation from the spec I noticed in Chrome and Firefox. I don't want to go too far into it because I think it's a pretty clear difference from the spec, and I think it's actually much easier to fix. and that is that the way time origin is set currently in Chrome and Firefox is a bit different from the spec. In Chrome, each time origin is actually synced to the system clock instead of from a shared monotonic clock. And in Firefox, on a per process basis, time origin is set off of the system clock rather than a shared monotonic clock. Again, I think much easier to fix, but I wanted to mention it just so folks were aware of it.
Seems like it would be useful to file like implementation issues on that front.
I've already filed issues on the Chrome and Firefox bug trackers. If there's something I should file with W3C folks, I'm happy to do that too.
Yeah.
Are we keeping track of this in the HR time bug that you opened? And if so, maybe just to add a little short sentence that says this is also an issue.
Happy to do that.
Yeah. That would be useful. Yeah. Yeah. Cool. Yeah, so yeah, thank you so much. I think that we're all in agreement that it would be great to have that happen. And then the question, like the main remaining question is how do we get there?
I just want to say I also appreciate, Jonathan, your attempts to normalize what SKU means across various CS disciplines. So I really appreciate like kind of meaning what we say and saying what we mean. I appreciate that. Thanks.
Yeah, on that front, do you have proposals for what other term we should be using? I don't know if there is one on the issue.
I thought adjustment was perfectly fine as a neutral term. I think giving examples of what's permitted and what's not permitted would really help clarify for implementers, namely anything that's non-monotonic, not permitted, anything that is big, that is sort of a bit subjective, but big, not permitted, and then anything that is monotonic and then either small or gradual, such as oscillator adjustments or clock skew, would be permitted. And then call it a day and just not use the term skew.
Okay.
And if it would be helpful, this strikes me as maybe a little in the weeds for a W3C document, but if it would be helpful, there could be like a non-normative box that just like, hey, implementers, depending on which operating system you're using, here are some of the options they might provide, and here's what those options might look like on some common operating systems. But that'd be pretty in the weeds.
Yeah, that seems like something that would be useful as a separate document potentially. Although, yeah, I haven't seen any other precedents of including implementation hints as a spec note, but it's definitely like the issue itself that you that you outline all the different options. That is super useful. It seems. Okay. Cool. And I think we covered that. At the same time, like we have 2 minutes left, which I don't think would be enough to start discussing any of the other issues. So with that, we can probably call it, and we will reconvene in a couple of weeks. Awesome. Thank you all so much.
Thanks, everyone.
Cheers.
Cheers.
I forgot to stop recording.